Welcome to the all the team member students. I think the students are from mechanical and civil, mostly core branches are here today. Anybody from computer science also there in today's session? Okay. So what I means today's I targeted how. When we say core branches, most of the time challenge is that to explore the data analytics domain or data science domain, the programming and lot of math or statistical concepts. So which most of the times the core engineering team lack it. But now that's why a new term is coined in the industry. It's called citizen data scientist. When we say citizen data scientist, so 80% of means his domain knowledge, whether it's from mechanical or electrical or telecommunication or civil, his domain knowledge will be useful, and we will use a lot of practical AI tools to where are the gaps, like where the programming or the statistics or deep knowledge of different machine learning models, we can leverage the practical AI tools to bridge that gap so that we can deliver or leverage data science for different engineering problems. So today so I will talk about, these are the areas I will try to cover. First, I will give you as I explained, that citizen data scientist. So how you can leverage different practical AI tools and build your different data science models for your engineering problems. Then I will talk about some buzzwords people are using, like AI, artificial intelligence, ML, machine learning, big data. What is big data? All these things we'll talk about it. Then how you can leverage different tools and with the basic knowledge of the machine learning algorithms and the basic knowledge of the statistics or mathematics, which all engineers, we have that background. Statistics and mathematics we have studied in our initial first and second semesters. So that we can leverage, but without writing single line of code also you can build different machine learning models. That we will see. Then I will talk about CRISP-DM process, which is the standard process for any data mining or data analytics projects. Then I will talk about what are the different use cases where this AI or machine learning can be leveraged in the engineering and manufacturing domain. Mostly I will concentrate on engineering and manufacturing domain today. Then I will talk about how, you can use practical AI tools, which without, I can say, low code or no code, without writing any code also you can build a lot of models and you can train your models, you can generate the code from the platform. But and if you have some expertise on the coding, that also you can leverage using Knowledge Studio. Okay, so what are the objectives we'll achieve today? So you will understand the general workflow and different terminologies of data science. Then you will understand that what are the tools you can leverage to where there is a gap, like your programming gap, or what means your data, machine learning models gap, how you can leverage that using the tools. Then finally, we will talk about different engineering use cases where you can, if you have thought already in those directions, you can leverage it. Or if you have not thought also, you can think about how you can add some more value in those engineering problems. So to talk about, I started with this slide so that you can understand that. See, this is taken from the journal where machine learning in engineering domain, and the publication specifically integration of machine learning and mechanical engineering. If you see in the 1990, it was so less in a single digit or a double digit. But if you see the growth of exponentially, how many papers are published in 2000, recently, it is crossed 7,000 papers. So I have not statistics of 2030 statistics, but it is exponentially growing. So you have, as you are budding engineers and your future of our country, so you have a lot of scope how you can leverage your core engineering with the latest technology kind of IoT, AI, machine learning to address some challenging problems in the engineering domain. You can see these are the different areas where mechanical or in the manufacturing industry where we will go. So if you see predictive maintenance, is like the highest, the maximum amount, means number of research is happening here. Then you can see that which Ramesa has showed a video at the end of his presentation, digital twin of the factory. So where like you can leverage your simulation as technology as well as machine learning technology, data-based models and simulation-based model to build a digital twin so that you can give real-time decisions. Think about like you're riding a very high-end car and your shock absorbers are like smart shock absorbers. So based on the road condition, automatically your shock absorber will get adjusted. So what is happening in the backend? It is happening like a digital twin. Like there is a Raspberry Pi or a small chip is there inside, which is getting the data from the accelerometers or strain gauges fitted on your wheels, and it is automated running a dynamic MBD model, and it is giving, and it is parallelly it has some surrogate models, I can say, which are like, because design is not changing, here only boundary conditions are changing. So it will run as a surrogate model, and it, in a few seconds it will give you that what should be the adjustment to be done on the shock absorber system. So that is kind of, I'm giving you a very small, easy example which you can easily digest, but it can be extended to anything. So digital twin of the product assets, digital twin of the products, and these are the, like you can see that the means why predictive maintenance, because there is a lot of cost involved. Means once you automate that predictive maintenance in a manufacturing industry, you can achieve the ROI very fast. And that the ROI is very, in numbers, if you quantitatively measure, it is very high. 10% of reduction in annual maintenance cost, 20% reduction in the downtime. Means when you say 1 hour downtime, it is a huge cost for a manufacturing industry. It can be a like big automotive industry, or it can be a simple part manufacturer who manufactures a bolt or a nut kind of small part manufacturer. So this is not the data coming from the McKinsey's 2017 artificial intelligence paper. So now I will go to the try to address some of the buzzwords. As I said that what is data science. So data science, I will not go the bookies the definitions. I will try to be more practical oriented because I'm from the industry background. So data science deals with the extraction of the knowledge from the data. Whatever you have the data, from that you will extract some knowledge which can be leveraged for addressing future problems or future solutions. So use of various techniques from many fields. And when you say big data, I will talk about in the next slide. If your data is high volume, high veracity, high velocity of the data, then we can talk about the big data in the next slide. So taking that data, use different mathematical models, probabilistic statistical models, machine learning models, then deep learning kind of neural network models. And we have to, when you have to take the data, you have to do some lot of signal processing, because data will have a lot of noise. You have to take some spectral features, or you have to take some domain features, so you have to do some signal processing in a mechanical language. Then you have to do all these things through some programming, because it has to be run automatically. It is like somebody will not sit continuously and use some tool to do it. So it can be the programming language, it is independent. Nowadays, these libraries are available, any open source programming, you talk about Python or MATLAB or any language you talk about, it will be there. Then data engineering, when like you are taking the data from multiple sources. You are taking a data from a Excel file, you have to take a data from a database like a SQL or Oracle, means whatever the database, or it can be a data lake system or a data warehousing system. I will not use much complex words. I understand that most of you are from the engineering background. So whatever the data, means you have to aggregate the data from multiple sources. So you might have mostly dealt with the CSV file or Excel file when you say data, but in a real practical industry, the data comes from multiple sources. It can come from a ERP system, it can come from a CRM system, it can come from a quality management system. So data will come from different sources, and every system has a background is a database. And the database is also again multiple type, means SQL, NoSQL, graph DBs, many type of DBs. And again, when you say SQL, in SQL also Oracle, SQL, Postgres, again multiple different type of DBs are there. So you have to take the data from, and again when you say data, it is like a structured data, unstructured data. So when you say structured, it is just simple rows and columns. Like you talk about Excel, you have some rows and some columns. So it is a structured data. But you think about a PDF file, like assume that I'm getting some or some text file. Assume that I have run some NAST run run means I have or a OptiStat run, and so I got a log file out of that. I want to understand that what are the different type of elements are there, and how many elements of each type are there, and what are the different boundary conditions are considered. I have to extract from the unstructured data file, means which is a log file or a text file. From there also we can use different data engineering tools and extract the data and put it into a structured format, as a tabular format. And pattern matching, data visualization. Data visualization is required is because when you have to deploy a solution in an industry, means most of them are not like pure technical background. The same means that whatever the dash means you want to build a solution, it will be used by the from the soft floor employees, like who might be ITI or a diploma cadre, and there might be some engineers who are BTech kind of graduates, and there will be like a manager, managers who might not be engineering background. They are mostly management guys. So when they have to understand and take a decision based on the data, you have to build some visualization dashboards. You will see when I will talk about some use cases later. Then computer vision is like everybody now you might be seeing like computer vision talk about a simple, if you are using a Facebook or some social media, when you upload a photo, automatically it tags your photo by looking at your face that this is Srinivas. So this is like computer vision. So it has learned based on different patterns. So as soon as when you upload a photo, it will automatically recognize that this is. So this they have built, Facebook has built this from last 12 years, and they are making that algorithm more smarter and smarter, so that it will reduce the time to predict and the accuracy of the prediction. All these things are improving. So think about like in a in a mechanical language. Let's suppose a product is coming out of a 3D printing machine. So when you give that product to the quality team, they have to do some destructive testing. But most of the time, you don't have the bandwidth to test. You cannot do the destructive testing for all the products coming from your in the assembly line or from the manufacturing line. So you will take a random sample and do the destructive testing. But when you're doing a random sampling and doing the destructive testing, you're telling that if you have taken 5 out of 100 parts, and you are testing that 5 are good, then you are assuming that with a 95% hypothesis, your rest of the parts also good. But may not be, right? That is not be the case, right? So nowadays, everybody want to real time put a camera in front of the part coming from the printer and predict the looking at the camera pictures, they want to predict the quality of that, the surface finish of that, or whether there is any you can put IR cameras which can take a 3D picture and it will deep dive into that, so that there is any pores or cavities inside that which is not visible on the surface also, you can understand that. So those type of IR camera pictures also can be analyzed using computer vision. Then last one is natural language processing. So natural language processing is like when data comes as a text, or like a social media text. Somebody in a Twitter, somebody has written some comment about somebody. So now it is like it is going through natural language processing, and it is finding out all the nouns, verbs automatically. And from that it is trying to understand that sentiments, whether there is that comment is a harsh comment, or that is a like a pleasant comment, or that is a neutral comment, or you can categorize based on your model. So it is nobody is continuously reading your messages. It is like everybody has put some NLP models, so it will automatically understanding what is the sentiment of that comment, and if there is something wrong is written about that company, then they immediately connect you. Let's suppose you put some comment, harsh comment against some company A, assume that some automotive company. So nobody is sitting there and continuously reading, because so many messages, so many comments comes, so nobody can manually read it. So it is going through a natural language processing, and it will flag it. it is a harshness is with 80% harshness is there. So then that comments only somebody will and read, analyze, and then they will try to reach to the source. What is the problem? How can we help? Like that. That is the way it is happening. The customer relationship management. So I will take into next step, like understand like what are the, when you say that you want to build a career in the data science, what are the skill set is required? So first is that math and statistics, that is the basic skill set is required. And most of we as an engineer, we have this. Then we should have the domain and basic knowledge. Domains means like which problem you are trying to solve. You are trying to solve a mechanical problem, you are trying to solve a electrical problem, or you are trying to solve a banking problem. So based on that, as we all are engineers, core engineers, mechanical or civil engineers. So our, which we study in this 4 years of our graduation or 2 years of post-graduation. So that domain knowledge is required, because without the domain knowledge only you have, means a data scientist cannot solve the problem. So they have to collaborate. That's why you can see like a Venn diagram here. Then third one is the computer science or IT, which is the biggest challenge for our core engineers. We don't have that software development background. And we don't have the deep like machine learning models or algorithms, that knowledge also we don't have. So how we can leave, means if you talk about, these are the different languages are coming, and these are the different statistics, means math, these knowledges we can get from online courses or from our graduation courses, if it is your college is providing, and you can go through different your own self-learning books, or you can learn that. And then domain and basic knowledge, obviously based on the profession. You are solving a engineering problem, you're solving a medical problem, or you're solving a banking problem. Based on that, that professional knowledge background will be there. As an engineer, we will solve engineering problems. So what is the lack in our, means when we have to address this domain, the major challenge we face is like the computer science skill set, the software development, machine learning skill set. So that we can leverage some practical AI tools. So Altair Knowledge Studio is one of the practical AI tool where without writing much code, you can build, take the data, clean up the data, you can explore the data, you can do some data cleanup, outlier detection, a lot of things, whatever a data scientist do, all these things you can do through a GUI. And without writing any code. And finally, you can generate different models, like depending on I will talk about what type of models, all these things you can do through. And finally, this platform will generate the code for you, whether you want to generate a Python code, whether you want to generate R code or a SQL code, it will generate for you. Some other buzzwords I will try to clarify, like means try to help you to understand. AI, machine learning, and deep learning. These are the nowadays buzzwords. Everybody trying to learn these skill sets and doing that. So I want to means you have to understand that what is the relation between them. So for doing any of these machine learning problems, the basic food is data. Without data, you cannot do anything. Whatever the problem you want to solve, because this is a data-driven modeling. Then you build different predictive models. It can be a regression model, it can be a supervised learning model, it can be unsupervised learning model, it can be a deep learning model, whatever. So all these things, learning building a predictive model from the data is called machine learning. And a subset of machine learning problems are deep learning. So where, like I was talking about natural language processing, I was talking about computer vision problems, or I was talking about, I mean, some problems we can leverage neural networks, how our brain works, like in different neurons works. That way we can leverage that technique, how it works. Same way we can build a neural network model. There are different convolutional neural network, deep neural network, KNN, augmented neural network. So many different neural network models, depending on the use case, we have to leverage that. So when in short summary, the deep learning is a part of machine learning, but there are other machine learning models like ensemble models, regression models are part of machine learning, which are not deep learning. When you take these machine learning models and deploy on a system, I will say a system, because it can be a car, it can be a robot, or it can be a, as I said, the Twitter. I was talking about that. Somebody put a comment, it will automatically understand that that comment is a harsh comment. The sentiment of the comment it will understand. So what it is doing, there is a hidden block in the behind the screen, and this is the front end for you. either a robot or a Twitter or a Facebook or a car which you are seeing. These are physical objects and these are like a website. So it can be anything. So they will, means what it is happening that when data is coming in a real time, it is trying to sense the data, act on that data, and then adapt that data to give different means based on the use case, based on the requirement, it gives a solution or it gives a prediction. That prediction can be useful for different uses. So in simple, like now I will go what is the definitions given by some famous authors in the past. Like artificial intelligence is a human intelligence executed by machines. John McCarthy in 1956. And machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Arthur Samuel is a very famous person. If any computer science graduates are there, they know it. So what it mean is like, let's suppose you say that, okay, assume that I have to write a simple explicit program to tell that this is, I will give you some images and tell that this image is a dog and this image is cat. So what you have to write, okay, you will see, and if you say that if ears are standing and tall, then it is a dog, and ears are small and it is falling, then it is a cat. The eyes are like this, then this is a dog. The eyes are like this is a cat. But that way, when you define it, there is endless if else blocks or a switch case blocks. You have to write it, and still you cannot say that that program is generic to predict any image you give a dog and a cat. It will predict that whether it is a dog or it is a cat, right? So there it machine learning helps. So machine learning, what it does, like beyond your like what human perception or human brain understands, it will try to understand different other things also, features, and based on that it will categorize that dog and cat, which is like the features can be, some of the times it can be like millions of features also, depending on the, like if you think about features in a Facebook, when you upload a photo and it automatically understands. So it is understanding like billions of people photos, right? Means it taking like millions of features and understanding that based on that feature matching, pattern matching, it is telling that this is Srinivas or this is Hari or some, it is telling that. So that is beyond our, so human brain's judgment. Human brain cannot process this much inferences in a single time. So you have to leverage a computer science, and that means computer, and that computer behind that there is a programming is required. That is a machine learning model. Some other key, so you might have heard in the data science or data analytics domain. These are the keywords: data analytics, data mining, and machine learning. So try to understand, as everybody understands this Venn diagram. So you can try to understand that what is the relationship between them and what is what. Like when you say data analytics, that is the, if you talk about, and this is the methods and algorithm, where this data analytics and methods and algorithm intersects, that is called machine learning. Machine learning is trying to extract the data, extract the relationship between the data, and then it will build some predictive models or forecasting models. So that is machine learning. And when you take a big data, the data will not be clean, data will not have a lot of outliers, and the data, whatever it comes, the raw data might not be useful. So you have to extract some features. All these things you do through, again, different data analytics technology. So that part is called data mining. And these, you have whatever the, you say that the data analytics or this one you are talking about methods and algorithm, big data. So big data means when you say that behind the scene, a lot of databases, data warehouses, data lakes are there. All are software tools. So when all this intersect at single place, that is called big data analytics. So any product like advanced AI product, you take it, or a smart product, it is handling a big data analytics problem. It is solving a big data analytics problem in the back end. So data mining is the process of extraction and discovering patterns in large data sets involving methods, intersection of machine learning, statistics, and database systems. And data analytics is the process of sourcing, cleaning, transforming. Means first, when you get the data, this is the first process. You have to clean, transform, analyze the data. Then you build different machine learning models. So that is the machine learning part, which are that there are different models you can build based on the business requirement. And the intersection of all are called big data analytics. So when you say big data analytics, the data in the form of terabytes or zettabytes kind of. So now let us understand what is, I mean, so we are talking in the previous slides, we are talking about big data. So big data is nothing but three V's. There are five V's also, but I will talk about three V's, which are very important. One is the volume. The data is very high. You talk about any social media system or e-commerce platform, or think about that you have put some IoT system, like you have put electric vehicles are running on the road, and a lot of sensors are fitted on that, and data is coming. So volume of data is very high. So when the data is volume is high, and second is variety. So let's suppose you think about a social media, Facebook. You upload photos, you upload comments, you upload videos. So and you upload like a friend's profile. So it has to understand the relation between these people. So this data is variety. Images and videos are like completely unstructured data, and you can upload some for like files maybe. So those some are structured data. So the data is variety is very high, and velocity. Velocity obviously means so billions of people are simultaneously using the platform. So a lot of data velocity is very high. Means you can think about like terabytes of data coming in a day kind of. So when this type of data comes, it comes with some other challenges also. Veracity. Veracity means how you will trust the data, whether the data is clean or there is some outliers. Variability. So data is variability means you cannot understand that what are the different variations possible in the data. So it is like a continuous learning process, and how to generate the value from the data and how to visualize the data. See, when I say that if you have to visualize simple structured data, like a data, taking a data from an Excel or taking data from a database and visualize it, is just you can visualize it because you just has to read some tables and you have to visualize either a pie chart or some heat map or a tree map or something you will visualize. But when the data comes in different unstructured data, you have to extract, means that visualization also very challenging. So, but without visualization, you cannot make sense of this data because this data is so huge. So these are the how when you will say that this is the big data and how what are the challenges comes with that with big data. So now I will talk about that like how I can define a simple data science problem. So let's I want to do machine learning. Is it a data science problem? No. Then you will ask that what is the thing you want to do means with machine learning. So as a mechanical engineers, I thought like take a small this example where you can relate it. So I want to build use machine learning to predict a time for a 3D part to print for a printing a 3D part. It makes sense now as a problem statement. Now you will ask me like when you have to predict the time, what are the parameters it depends the 3D part, and what are the data I have to predict that time. So then it will you will elaborate the problem. I want to train a machine learning model to predict the time to 3D print a part based on its shape and material, because normally 3D prints time is dependent on the what type of material. If it is a very simple material, it can be printed fast, but if you think about a metallic 3D prints, then it will take a lot of time. Then complexity of the shape and size of the shape. Then now if based on the shape and material you have to predict it, then what data I have, like without data I said, right, we cannot build a predictive model. So we have collected previous designs, like let's suppose in the past I have done a lot of 3D parts printed, and I have noted down their shape parameters, their material parameters, and how much time it taken. Then taking that data, I can build a machine learning model. So now you are coming into like step by step. So how you are trying to approach the problem and elaborate the problem. Now I will define, like, the goal is that I want, predict a 3D printing time of a 3D part. So when you are predicting a continuous variable, that is called a regression problem. So you are trying to predict the time. Time is a continuous number. It can be a float, it can be integer, whatever, but it is a continuous number. And what is the data? Data is in hand, like, because you have, like, in the past you have done some lot of 500 parts printing in the past, so you have that 500 parts data. So that is data in hand. If data is not in the hand, what you can do means you have to generate the data. So that can be generated using some DOE setup, or you can take the data from us and doing some simulation, or some data you can take it from some IoT sensors, like you can stream the data from an IoT system. But current, if you have the data in hand, it is nothing better than that. Then what are the different data types? Data types can be numbers, or it can be strings, it can be a CAD part, it can be a FEA part, or it can be anything. So when you, so images, anything. So these are like all unstructured. But when you say numbers and strings, these are comes as a structured data. And data is labeled. Data labeled means like what you want to predict. You are trying to predict the 3D the printing time. Whether in your 500 models, whatever you have, that time is there. This is the what you want to predict. That time is there. That is, we say, labeled. If the time is not there, then it is a unlabeled data. Or some parts you have time and some parts you don't have. Then it is called partial labeled. So if means I will talk about in the next slides, when the data is labeled, then we say we will build a supervised learning model. When data is not labeled, we will build a unsupervised learning model. So now you are trying, you are able to define a problem statement in what you want to do. So this is just an example. So how, whenever you get a problem, like somebody will say that I want to build a machine learning model, that just a machine learning model doesn't make sense unless you define the clear problem statement. So now you will see that what are the data I have, what format I have, and then how I can, then you can have an approach to solve this problem or build the machine learning model. So now we learned what are the different data science skills and some buzzwords, and we have learned how to define a data science problem. So whenever a data science problem comes, it always follows through a process called International Standard Process, CRISP-DM process. So CRISP-DM process is nothing but cross-industry standard process for data mining. So either it is a small POC kind of proof of concept kind of project, or it can be a very big predictive maintenance or quality monitoring or asset monitoring kind of project, big project also. Every project in the data analytics follows this process, this DM process. So this process starts with the business understanding. So when you say business understanding, because you are trying to solve a business problem, right? We might be engineers, we are technical guys. Finally, we are solving a business problem. So that problem is like whether you want to monitor, you want to predict the quality, whether you want to predict that what is the machine downtime, or whether you want to forecast it that what is the demand for this part in next 1 month. So what you want to, so that is the business understanding. You have here in the previous slide I was talking about predicting the 3D printing time. So if I can predict the 3D printing time of a part, then let's suppose I got, assume that I am in the industry, I will get 100 part to this thing, 3D printed. I have a 3D printing factory, and somebody came that I want to give me a design, and he told me that this is the material, and you print 100 parts. Then I have to, what I have to tell, first I have to tell them that how much time it will take, whether it will take 1 week, or whether it will take 2 weeks, or it will take 1 day. And second thing, I have to tell him a cost, like I will take this for these 100 parts this much. How will I arrive at the cost? For that, I should have this background information, right? Like what is the complexity of that part and how much time it will take. Because I have a 3D printer, I have to add the material cost, and I have to add the machine cost. And so the machine cost is directly dependent on how much time it will take, right? So if I have to give answer for how much time it will take to print the 100 parts and how much cost it will be, I need the time. So that is my business problem. So in spite of, if I, let's suppose I guess it, like based on my understanding, my domain understanding, I will guess it. if it is goes wrong, I mean, say if it is not very accurate, means because whenever it is a human guess, it is always depend person to person, right? So but when you I mean, build a machine learning model, it will be most of the times like it will, I mean, there is no human bias will be there. So the whatever the output will come without any bias. So that will help me to fast forward my process to estimate the cost, estimate the time to do it, and all these things. So that is my business problem. So for that data understanding, as I explained that in the previous problem, what data I have, whether I have in the past I have printed 500 parts, whether I have the shape information, whether I have the material information, whether I have the print, how much time it took, all this information I have. Then what is the format it is? It is in a like Excel file or it is in a database, what format is? So I have to take that all that I have to understand that all the information. Then only I can take do the data preparation, because whenever you have to build a machine learning model, you have to prepare the data. You have to clean up the data. You have to process, extract some features of the data, and that data only you have to take it. You cannot take a PDF file and input to a machine learning model to predict something. So you have to input a table, a rows and columns table. The rows are like the data points and the columns are like variables, the parameters, independent variables or dependent variables. So this is, as I said, that means we will go through the process. I will go in the next slides in more deeper. So this is a industry standard tool. We follow it to solve any data mining problem. So what I mean, trying to, I mean, here drawing an analogy between normally when as a mechanical engineer, you might be doing like CAD and CAE. CAE means computer aided engineering, where you take design part design and you mess it. I think I don't know which year. I mean, whether it is covered in your FEM finite element method. Those things are covered or not. But normally, when we say that computer aided engineering, that goes through this process. It take a mechanical problem, means whether it is a structural problem or it is a thermal problem or a computational fluid dynamics problem. Then we take that model as a CAD file and we will mesh it as a pre-processing, we say. Then after meshing it, we will solve it some solver. It can be any solver depending on what type of analysis. Is it implicit analysis? Is it explicit analysis? Is it a linear or a non-linear? Is it a multi-body dynamics or is it a computational fluid dynamics or it is a, so all this based on static, it is just a static analysis. So based on that, you will choose the solver to solve. Then once it solve is done, then you take the results, then you post process it to understand that where is the maximum stress, where is the maximum strain, and where is the stress concentration is happening, why it is happening. So for all these things, you do post processing. If it is a transient domain problem, means the problem is solved in the time domain, then you will plot it and understand like how the data is varying. Then you will see that okay, there is some stress concentration is happening and you want to improve that. So let's suppose you want to add a fillet there, or you want to add a notch there, or you want to finish the surface at that. So that is the design improvement suggestion. So you give the design improvement, then again in the CAD part, the design will change, and again it will go through the pre-processing, solving, post-processing, till you meet the final year. What is the expected behavior of that, you met that. So same way in this data science also, it follows the similar analogy only. So you understand the problem, then you understand that what data you have. Then once you have the data understanding, then you have to take the data, I mean, whether the data can be directly usable, or I have to do some cleanup and then only I can use, or I have to extract some features. All this part of the data preparation part. And sometimes it happens that you don't have enough data. You might have very less amount of data. So you have to generate some synthetic data using some DOE or some simulation or something. So you have to do all these things in this part. And once data in a structured format, clean format, then you build modeling, then evaluation, then deployment. So for all these things, data is required. So okay, let me explain here. So then why you can see that there is a arrow from evaluation to again business understanding. So why it is happening is like sometimes assume that you build a machine learning model to predict the let's suppose printing time. and then you took that design and then you try to print it in the 3D printer, and you find that the 3D printer, whatever you predicted, let's suppose you predicted 1 hour 20 minutes, for example, but the 3D printer took 1 hour 40 minutes, for example. So evaluation, you whatever you have predicted, didn't go good. Then you will again go back to the business understanding, whether only material and shape parameter is enough, or whether I have to take some other parameters, maybe machine parameters. You have not considered machine parameters. You have taken only external parameters, material and shape of the 3D printing part, but you have not considered machine parameters. So whether that is need to be considered. So that comes from the domain knowledge. Business understanding is nothing but our engineering domain knowledge in an engineering problem. Then you take that machine parameters, then again take the data, understand that parameters, take the data, prepare the data, again it will come as a cycle. So the data means the CRISP-DM process is like a cycle. So in the business understanding problem, you have to address few of these questions. See why I am putting this. I mean, so like normally as our engineering, I mean, so academic background, we normally don't think it. I mean, these are the questions. So these are the questions you should answer when you are trying to solve a real means business problem. So what is the biggest business challenge in engineering? Where do we expect AI/ML to help? And do we have a good data? Why I am asking these questions? Assume that if I am solving a data analytics problem is very costly, because you have to generate the data, you have to understand the data, you have to clean the data, you have to model the data, then you have to evaluate, then it will build, you can build a model. It will take you, means it takes a lot of time and means energy. So after doing that, you are just doing it and there is no business ROI is there, then you should not take up that problem. Either it can be a business ROI or it can be a technical ROI, but there should be some, you should achieve some challenge, means you are addressing some challenge. So that is more important. So many of the times it happens in the real industry, like just because of the passion to leverage machine learning, people are taking some problems and they spend a lot of energy, a lot of time. Finally, after solving that problem, they felt, but as a company perspective, they are not getting any benefit out of it. So that is why business understanding is very important. And second thing is that whether that problem can be solvable with the AI/ML, with the data we have, that is also important. That's why what we expect AI/ML to help here, that you have to understand very clear. And we have the good data to analyze. But if you don't have good data, it is means I suggest you that drop that problem, think about another problem. Then once you have the data, so data, as I said, so like initially I was talking about, like data can be structured, unstructured, and semi-structured. There are three types of data. When I say structured, it can be a rows and columns of data. The data can be in the form of an Excel file, or it can be a CSV file, and or it can be a SQL database, some database. When I say unstructured data, like as I said, photos, videos, audio files, text files, CAD files, PLM files, or CAE files, all these are like unstructured data sources, where you cannot extract the data in a simple rows and columns format. There is another data source, is semi-structured data source. When you say semi-structured, as I said, that you think about a log file, or think about Excel balance sheet, or some Excel file, which is not simple rows and columns. Some rows are merged, some columns are merged. It is a very complex Excel. You might have seen many Excels in your life. So that type of Excel, we say that semi-structured, because it is not simple rows and columns. It is Excel file, but it is not simple rows and columns. So from that, how we can extract the data? Or think about an email. How I can, somebody has sent an email. From that, I want to extract the data which is required for me. So that is called a semi-structured data. We have different techniques to extract the data out of a semi-structured file. So semi-structured is mostly, it is a ASCII file. It is not a binary file. So you can, copy, paste, you can do all the things. So that is called semi-structured. So a PDF can be a semi-structured, but a PDF, it is a scanned PDF. Like somebody has just taken a photo and converted into a PDF. That is not a semi-structured. But if your PDF is like you have taken a Word file or something and converted into a PDF, and where you can extract the data out of it, that is called semi-structured data. So now you understood what are the different data types. Now question comes like the whether you have the data. So you might have seen data in hand. I have rounded in the when I defining the problem 3D printing part. So that time I have already 500 parts data I have in my hand. So data in hand, which is like historical data. I have to just take the data that might be in Excel file, that can be a means database. I have to take it, but it is not true always. Many of the times, data will not be in a file. So either you have to generate the data on demand, or you have to data generate on the fly. So if I put some sensors, think about electric vehicle, means this I want to build some solve some problems on electric vehicle. So obviously I have to means put some sensors in the vehicles on the road, and I have to take that battery temperature, battery capacity, voltage, current, all this. And I want to understand that remaining useful life of the battery. At any time, I can tell that after 10 means maybe another 58 days, the battery need to be replaced, because that is very important. Let's suppose you have planned a long trip and your battery is down, then you cannot means you will face a lot of difficulty on the way. So you better take care of that and do it. Or like you're running a battery and you know that you means nowadays obviously like people are running the electric vehicles inside the city, but you know Tesla and all these vehicles, they are running like intercity also. Like it is one charge, it goes up to 250, 300 kilometers. But how much charge is pending for means how much distance I can go with the available charge? That is again a machine learning problem. So for these type of problems, you need to generate the data, putting some sensors and operational data you have to take. That is called data on fly. And data on demand, you can use some DOE setup or some simulation to generate the data. Think about that I am solving a mechanical problem. Think that shock absorber system problem. So what I will do that I will generate means very different road conditions, and I will generate the simulations and solve that problem as a simulation and generate the data. And taking that data, I can build a machine learning model. So in nutshell, I can say in data science projects, often 80% of the time we don't have means we have to extract, don't have data in hand. So we have to take the data and we have to prepare the data. So this is like means data on demand, how we can using the simulations or using the different DOE setup, design of experiments, we can generate the data. So there are different techniques are there. So we can use any of these Latin hypercube sampling or Hammersley sampling methods of extensible lattice sequence. So these are the different sampling techniques we can generate the generate the data, synthetic data. So if you talk about, means from my practical experience, I'm telling that if you talk about only 12% of enterprise data is used for making decisions. They go to any enterprise, any company, they hardly use 10 to 12% of the data to build, generate different insights using machine learning. Rest means around 88% of the data they have not explored at all. So the data is in these formats: reports, web pages, JSONs, log files, machine data, streaming data, etc. So if you can extract the data out of this 88% and take into consideration for your machine learning model building, you can build more stronger and more accurate models. So data on fly, like as I said, that if your data is not there in your hand and you cannot generate simulate that system, then you have to take the data using some means IoT system. You can take these are different real-time streaming feeds. Maybe, means if you are from telecommunication or electrical background, you may understand that Kafka, MQTT, UDP, HTTP, ActiveMQ. These are the different real-time streaming feeds. So we can take the data from any of them. So Altair has a SmartWorks platform and a Panopticon platform, which has real-time streaming and visualization. Means you can do real-time streaming and visualization. So you take the data, you have to process the data. It is called complex event processing engine. Then you have to extract the different features using different techniques. You can write a simple R or a Python program. You can write a MATLAB program and export as a REST API. So these are like different techniques. You can use it to extract the data and you can visualize it on a dashboard. So these data also very much important. You have to generate when there is no data. So once data is there, then you can build different modelings and evaluate your models. And these are the different models you might have, means regression, decision trees, clustering, random forest, statistical descriptive, like k nearest neighbor. So these are the different models depending on the business problem. So it is showing a statistics. Majority of the problems are regression problems. 56% of the problem. So now, okay. Okay. So now I will talk about, the deep dive into what is regression problem and how means a regression will work. Means as I said, the regression problem is nothing but when you are trying to predict a continuous variable. It can be a time, it can be a cost, or it can be a displacement. Means in engineering CA problem. Let's suppose this is a plate, cantilever plate, and the thickness is a variable and the length, the breadth is a variable, but I have considered, means just simplifying, just I'm taking one variable only. Thickness is the only variable change. Material parameters, everything is fixed. Length, breadth, and everything. And loading condition also fixed. At the free end, you are applying the load. And you have, when you vary the thickness, these are the, you have got maximum displacement. These are the different variables. Now I want to give you a completely different thickness, which is you have not measured till now. So you build a machine learning model, and that machine learning model, you just input the thickness, it will, without doing any simulation, it will tell you the max displacement. So when you say regression, you are fitting a, if you think a linear regression, you want to fit just a simple line, straight line. So the linear regression is y is equal to mx plus c, we have all know. So similar, it is like a beta 0 plus beta 1 x1 plus c epsilon. One small error I have introduced because it is not fitting all the points. So if you you see this is the epsilon. So for some predictions the epsilon is 0, some very small, and some predictions epsilon is very high. So the problem is that it is an optimization problem. So you want to find out a straight line, good straight line, where the error is 0. The y1 cap is the what is predicted, and y1 is the, which is the actual prediction, actual displacement. You want to minimize this problem. So that is the best straight line for you. If you are if you want to fit just a linear curve, a one order curve. But there is a limit. After whatever you do, you cannot fit a linear curve. So then what we can do is that I can think of okay, second order. Either a second order curve better fit. So you can try it, second order curve. So all these things are happening, like these maths are happening in the backend. Just how, for your understanding purpose, I'm going in deeper level. But when you talk about these machine learning tools, or some you are using a site, if you are using open source like Python, Scikit, or Learn or something, you just call linear regression, automatically the model has coded, like it will try first a linear model, then it will try a non-linear, like higher order models, it will try to increase, finally it is solving the optimization problem. It is trying to the best fit curve. Right, but the complexity will increase when your number of dimensions will increase. Means this is just I'm talking about a thickness. So it is a simple 2-dimension where you can visualize it. But you think about that, I will talk about multi-dimensions like a thickness, width, length, material parameters, Young's modulus, Poisson's ratio, and I will say that load also will change. So when I will add those complexity, then it will be more complex problem. So maybe sometimes the machine learning means a simple regression model will not fit. So you might have to think about a deep learning model or a ensemble models. I will not go into deeper on those what are the different type of ensemble models, but I'm just give you some highlight on that. So how normally a machine learning model is built? So you take a data, and data is clearly, I mentioned, it's structured data. It is like simple rows and columns. how many means different variables. You say that thickness, length, breadth, material, Young's modulus, Poisson's ratio, loading. All these are like your dependent parameters, and you want to predict the max displacement, max stress. So those are all independent parameters. So all these things will take take the data. It is a labeled data and it is a structured data, and you build a machine learning model. That machine learning model can be a linear regression model or an ensemble model or a deep learning model. Then you evaluate that model with some unknown data. You take some data, but you keep some data which is not known to, means not fed to the machine learning model, and validate for validating. Then once your validation and your means training are coming good, means based means the variance explained or mean square error. These are the different matrices we see in a machine learning problem. So based if you find that they are satisfactory and that is like close to each other, means you can accept that model as a machine learning model for predicting your future designs. Then you finalize that, and that model you can take it and deploy. So now I will come into like what are the different type of machine learning models. As I said, that supervised learning model is like where the data is labeled, and means either whatever the variable you want to predict in your historical data, the data is labeled. Like you want to predict the displacement, you have done so many simulations and you have extracted the max displacement and you put it in the data. Or let's suppose you want to run a quality problem. Either this product is quality is good or this quality is bad. For each data you have labeled it. So you have input attribute variables and you have the outcome, means what is the output or outcome target, all are there in the data, and you build a machine learning model out of it. That is called supervised learning model. Unsupervised learning model, where like your data is not labeled, this outcome is not labeled. So you have just input variables and you have to predict it. Think about that. For example, somebody have given you some bunch of images, means which is easy to understand. Some dogs, cats, cows, buffaloes are there, and it is not labeled. This is a cow, this is a dog, this is a cat. Like that, it's not labeled. The image is not labeled. Just some images. You have some 1,000 images. You fed it to a unsupervised learning model. So the machine learning model, what it will do, it will try to extract the different features and it will try to group them, cluster them. So it will group them, means cluster 1, cluster 2. It doesn't know, right, whether it is a cow or it is a dog. You have not told that. So it will just cluster that these are out of these 1,000, these 350 are group 1, these 250 are group 2, these 250 are group 3, and 150 are group 4. Then you see that means most of the cows will be in one group, so you label that as a cow group, and most of the dogs will be in another group. You can label them as a dog group. So now your machine learning model is finding the features, and based on that feature, it is grouping them. So that is unsupervised learning. And the reinforcement learning model is like completely different. Like it is a maximizing a reward function based on improvement. Think about the most of you might be playing video games. So you play chess game with the computer, right? So chess is, the game is deciding what move. Based on your move, it deciding that what move it has to take. So that is, it is learned, the algorithm is learned by itself, the chess, how to play chess. And it is learned so much that now it is like expert than you also. So how it is learning in a very basic, so we will not deep dive into that very basic level. When that game, the program is doing a right move, then you reward it. When it is doing a wrong move, you penalize it. So it is automatically understanding that, and how much made a mistake, that much the penalty should be like it will be 0 to -1. And the if reward also like a 0 to +1. So you can give if it's a very good move, you can give 1. If it is a rewarding, or if it is like a partial good move, you can give it as a 0.8. So that algorithm works like that, and slowly with playing with the different human beings, the program become expert. That is called reinforcement learning. So I will talk about some supervised learning models. In supervised learning, again, two type of models will be there. Two type of models. One, when you are predicting a outcome, is a like a yes or no, like some classification. is good or bad. It can be no binary classification like yes or no, good or bad, or it can be multi-class classification like okay, average, very good, excellent. Kind of you can have a multi-class classification also. So if that is the case, then we say that logistic regression. When you are trying to predict a continuous variable like what is the house price based on different parameters of that house, or what is the cost of this part based on the different, or based means predicting the 3D printing time based on the different parameters. When you are trying to predict a continuous variable, that is a linear regression problem. Then there is an unsupervised learning problem. As I said that I throwed some like here it is showing like some dots, like I throwed some images in unsupervised learning, and the machine learning algorithm automatically grouping them based on some features. It is finding that which are very close to origin as one group, which are at the center another group, and which are completely away from the center, it is the another group. So it is labeled. So then you label it like this is far group, this is means center group, this is close to origin group, kind of. You name it, those group. So these unsupervised learning techniques are used for different uses like anomaly detection, outlier detection, all these different techniques. Means we use different techniques to find out whether you are means let's suppose in a mechanical language you're taking the different machine parameters, and in a real time you're telling that that machine is working in good condition or a bad condition. So those are like anomaly detection models. Or some like think about outside engineering. Think you might have heard fraud detection. Let's suppose somebody is using a credit card and somebody has tapped your credit card credentials and he is using wrongly, maybe in a different geographical region, or he might be using in a website IP which is not belongs to India. So let's suppose 5 minutes back somebody is using in India, and after another 5 minutes it is used in Croatia. It cannot be possible, right? So it will automatically flag that this is a fraud, and it will not allow to do the transaction. So this has to happen in a very real time. So just I'm giving you different kind of examples so that you can correlate. So these are the different algorithms. I will not talk about reinforcement learning. That is again a big topic. I will so we'll mostly the supervised learning and unsupervised learning, and in supervised again regression and classification. And these are the different machine learning models in regression, and these are the different machine learning model for classification type of problem. Similarly, unsupervised learning, again, two type of use majorly divided into clustering, where in the previous screen, I was showing you like it is trying to cluster the points, or I will give you some images, it will cluster those images. So those are like clustering. And another one is dimensionality reduction. So when you have large amount of dimensions, it is always computationally intensive to solve that problem. So we use some principal component analysis or autoencoders to reduce the dimensionality using an unsupervised learning. So in a linear regression problem, these are the different, just I will skip because we are about to. So this is like predicting the house price based on the different parameters, number of bedrooms, locations, what is the size of the house, number of square feet and all. You're trying to predict the best fit model, and you are predicting using building a linear regression model. Similarly, neural network models works like exactly how our brain functions. Inside the brain, different neurons functions. So assume that you want to predict something, taking different parameters, shape, color, and taste, and based on that, you want to predict the output, whether what type of fruit is this. So it is like just simulating the functionality of a brain, and it will it works. It will train the neural network model to predict. So this is a very simple a one-layer model with the 3 neurons. This is a more complex, multiple neurons, multiple layers, hidden layers. And this is just artificial neural network. Similarly, convolutional neural network, deep neural network, many different neural network models are there. And there are different hyperparameters need to be tweaked based on the requirement and data. So now I will talk about, like, when we talk about analytics, data analytics, this goes through a maturity curve. So first, what we do a descriptive or diagnostic analytics. So what we do, like whatever the data we have, we want to understand the data, and I mean, we will see, I mean, build some different dashboards and analyze the data, what the existing data tells, generate some reports or visualizations. Once you have the understanding of the data, then you try to build the insights out of the data. So that is called predictive analytics. So you build a predictive model for predicting the machine health, or you want to predict a model for predicting the you want to build some designs and you want to predict the maximum stress or maximum strain. So depending on that, means what is your predictive problem. So first you have the data, means you see the data and diagnose it. Then you build a predictive model. Once you predicted, let's suppose you predicted that when you change this design, you are predicting the stress. But is it enough? But what is the goal is that you want to finally optimize your design. You have some design responses, means you have to get it. You have to achieve that. So that is called prescriptive analytics. So you say that I want to achieve these goals. So what are the optimum parameters I have to tweak it, and what should be the optimum range of that? So that is called prescriptive analytics. Or in a perspective of manufacturing, if you see, let's suppose you are finding based on the current machine parameters, you are predicting that there is a some anomaly is there. Anomaly means there is a problem in the machine. What is the solution of that? How to solve that problem? So that is called prescriptive. So descriptive, predictive, and prescriptive. This is very important. Remember. So every industry, that's why we say that x-axis is the maturity curve. So it means every industry starts here, descriptive analytics. Then once they will mature, they will talk about predictive analytics. And the highly fully matured enterprises are they are trying to leverage the prescriptive analytics. So I'm trying to correlate my each step that the data mining process, so that you can understand that. I was talking about business understanding, then data understanding, data preparation, modeling, and evaluation. Till now I have talked. Now we are talking about deployment. How you will deploy this model? You build some machine learning model. How will you deploy that? So there are multiple ways you can generate. Means nowadays a lot of there's a practical AI tools are there which generate the code for you, a Python code or a Java code or a SQL code, which can be directly deployed on the web application or whatever that application. Think about that. If it is a Twitter, I was talking that doing the sentiment analytics. So there you generate an NLP model and it you deployed on the backend of the as a web app in the Twitter. Similarly, you are like an e-commerce player. You are selling and you are building a recommendation engine. Recommendation engine is like whenever you are going to buy something on the Flipkart or Amazon or how you select jeans, for example, that means denim. Then automatically it will show you like what shirt goes on top of it and what shoes will go better with that. So that means it will say that people also bought, who bought this, they bought this. So it is showing those things. That is called recommendation engine. That recommendation engine again a machine learning model is running, and it is trying to understand that so with this, what is the perfect matching with the other which other items a buyer can, user can buy. And based on your taste, like which brand you bought last time, what cost range, whether you are buying a shoe in the range of 1,000 to 1,500. So if I show you a 5,000 rupees, obviously you will not buy. So I have to show you, and let's suppose you are mostly buying a Nike brand or a Adidas brand. So better to show that a Nike or Adidas brand and in that range, and what type of colors you choose, what type of material, sole material you choose. All this data are there in your like when you are browsing any e-commerce app, it stores continuously those data. So based on that, it will show you top 5 recommendations or 4 recommendations, because in your mobile screen that much only space, you cannot show 1,000 parts, 1,000 recommendations. So all these things are happening as a part of deployment. So I will talk about few use cases in engineering domain. So in an engineering domain, these are the different use cases throughout the product cycle, life cycle. So you talk about like whenever the product life cycle starts with a concept, right? So you in the concept design, we are talking about generative models, data driven digital twins. So generative models means like people nowadays means if you are using Katia or Autodesk Inventor, it has already a generative design feature. Like you say that I want to build a chair, for example, just a very simple example I'm telling, four-leg chair. So it will give you based means you define, it will take you some inputs from you, means just some questions, and based on that it will throw you some thousand designs, and you decide that which is the best design for you and take that design and just modify the design based on your requirement. So that is called generative designs. Then CAE. In CAE, I have given you already example how you will predict different CAE responses in spite of going through a simulation, physics-based simulation. Shape optimization, all these things are part of that. Design optimization, how you can consider different domain disciplines. You want to multidisciplinary optimization to save the reduce the weight, improve the performance. All these things you can do using leveraging the machine learning. Verification. So people are doing a lot of physical tests. So how you can reduce, because each physical test is so much costly, because you have to completely define build that prototype, and the cost of the building the prototype, time, and testing. The testing setup is very costly. How you can reduce that verification, number of verifications? How you can improve the product quality? So how you can improve the product quality? How you can understand what are the factors are influencing root cause analysis? All these things you can do. Predictive maintenance, when you're manufacturing, how you can make sure that you're down less unplanned downtime. So machines should not unplannedly it should down. So how you can do the predictive maintenance so that your machine life will increase and unplanned downtime will reduce. How you can reduce the cost, warranty cost, parts of price optimization, all these things you can do. Customer satisfaction, this is again a customer lifetime value. If some customers are leaving, why they are leaving, what might be the reason, or you have to attract some more customers, then what type of discounts or what type of schemes you will get it. So all these things are machine learning models are helping them, the business decisions. So just giving you very, so for a mechanical core engineering, the classification machine learning is supervised, unsupervised, regression means like predicting some response, a response. Classification, if you are messing it, telling that which is the good mess, good is the bad mess. See, by normally means by looking at it, you can tell it right as an expert in the messing. So how your machine learning model can leverage for to do that. Clustering, like as I said, that you throw some fasteners to the system, it should automatically classify that which are the nuts, bolts, rivets, kind of. And feature extraction. So feature extraction, like let's suppose it is not meeting the your some responses, CA responses. So what feature you have to improve? The prescriptive analytics also you can do through this. So this is like I'm showing you some example where you can understand that these are the different parameters. Means people, it is still gone ahead. Means the CAE. So we are doing some CAE simulation, and this is like an impact, like this the golf bat. It is hitting to the ball, and there are different stresses. Are it is a stress contour. So von Mises stress contour. So when you change these parameters, automatically you without it is going through a physics-based solver. Let's suppose you are changing the length of that, or either you're changing the width of it. The contour will automatically, you can see that it is changed and the contour is automatically updated. So if not, you might have again meshed it, and you have might have solved it, post-processed it. You might have to wait, and automatically it is showing the output variables, the weight, performance, durability, yardage, all these thing parameters it is showing here without going through a CAE cycle. Just I'm showing a very simple example so that so I don't want to make it your life complex. So I'm showing so that you can understand it, how machine learning can be leveraged. It is a kind of like a multi-response regression problem. It is predicting multiple responses based on multiple design parameters. And these all things can be done with our platform name. This is HyperWorks. Through Design Explorer, you can do it. This is as I was talking about clustering. So just I will show you one example. So you means this is means again HyperWorks, and I loaded a complete assembly, and I'm trying to group them, the similar parts. So what I'm doing is that I'm selecting all the parts, and automatically it will group them based on the shape AI, means based on the shapes. So it is running that algorithm and it is grouping that. So now you see in the left side, this is this thing. It is grouped. You can say it doesn't know that what is the group, but it is said that group one, group two, group three, kind of it is there. You can see when it is highlighting, you can see all similar features. It is grouped into one part, like all these type of fasteners or. This is unsupervised learning. I have not told that based on what features you have to do. It is just taking some features, understanding the features, and doing it. I will talk about one example on predictive maintenance where anomaly detection we have. So it is like just a demo setup because I cannot show you a real industry problem. So it is a simple motor belt driven drive is there, and this is a simulation model of that. And these are the different technologies are required to build this digital twin: machine learning, data intelligence, internet of things, because you are taking the data from these motors continuously and feeding it to the machine learning model, and a simulation model is running. So the data is coming through means I'm showing you what are the different conditions I'm monitoring, whether the coupling is alignment is correct or not. Belt drive has means is it in a proper tension or not? If it is loose also problem, if it is very tight also problem. So I'm continuously monitoring that. The tension quality. Then stability of that installation. Is there any vibrations are there? Balancing of this rotor, whether there is any shaking is here, or then bearing the wear and tear of the bearing. So these are the different type of failures can happen. Means any of these things doesn't meet, then it may fail. So I'm really taking the data. The data are like accelerometer, strain gauges, motor, means current, voltage. These are the different parameters I'm taking, and I'm built a machine learning model out of it. These are like back end what is happening. It is taking these different spectrograms. I said that data, whatever comes, you have to extract some features, and based on that, you build some machine learning models. So it is automatically based on that. It is telling that means the bearing health is fine and the belt is tension is bit less. It is running at 95% efficiency, and this is some installation has a stability problem. So these are the things it is showing here. So that in a means when you create this as a dashboard and deploy it on real time, a factory floor engineer, a diploma or ITI engineer also can understand and how my machines are running and what care I have to take, whether I have to shut down it or whether I have to stop that machine or something, whether I have to increase the voltage, whether I have to decrease the voltage. So in short, like in means if I aggregate into different means problems in the manufacturing engineering, either it comes under product development or it comes under manufacturing operations. So either product design, as I said, digital product structure, virtual validation, smart products, like I'm talking about smart connected products, digital twin. In the beginning, I gave an example of the shock absorber system of a BMW car, automatically adjusting. This is called a digital twin. Remote monitoring and process improvements. This is any factory because of the if you see in the last 2 years COVID, every factory is running at 30%, 40% manpower. So in that case, if you are not able to monitor remotely your machines or your assembly lines, it's very difficult to run at 100% efficiency, right? So remote monitoring is very much nowadays, like it is very important. Everybody is going towards that. Predictive maintenance, prescriptive maintenance, software efficiency. Software means smart. I mean, that's what we say, smart factory or digital factory. How you can improve the product quality, how you can understand the root cause of that some product quality is failing. and AR, VR, augmented reality, virtual reality, how you can leverage this to train your workforce. Augmented reality, virtual reality, you might have, many of you have already explored. If you have in some, there are many like devices came. Means earlier it was very costly. Now it is very cheap. It is not very costly now. So in all these things means can be these type of areas can be addressed with data analytics, and we can improve the efficiency, quality, and performance. Just I will play this one small video to understand what the different problems can be solved using machine learning in mechanical engineering. So there are like just 10 I showed, but it is not like only 10. Just few I have took which are very important and showed you in that video. So just last 2-3 slides we will close and wrap the session. So what is the in the beginning I was talking about how you can leverage as a core engineering team, and how you can be a citizen data scientist. So what is the skill set is required. Normally we have as engineers, core engineers, we have the domain expertise, basic programming skills based on your interest, basic IT background, basic statistics knowledge as part of our engineering knowledge. But an expert data scientist requires strong statistics knowledge, good programming skills, strong IT background. So how you can bridge that gap? So you only way is that either you learn all this skill set and you become expert data scientist, or what you want to leverage your domain expert and how you can take benefit of some practical AI tools, which you can see practical AI tools. So Altair means you can leverage Monarch for data engineering, Knowledge Studio for data science, and Panopticon for data visualization. You can leverage for become a citizen data scientist to expert data scientist. These are not required any programming and not it required a lot of time to learn. It is very fast forward process to learn and to become an expert data scientist. Just these are the, as I said, Monarch is a data preparation, Knowledge Studio is machine learning, and Panopticon is a streams visualization. So in the Ramesh showed you, so we have different training content he was showing in that. So we have Altair University, so you can go through there, and all these lot of training courses are there based on your interest and based on your bandwidth. You can learn different, and there are different contests you can see here. Like recently we have conducted a technical contest on Hackathon 2021. So if you want to participate any of these contests also, you can participate. And we have a Altair community blog, and this means different like forums are there. In one forum is there, engineering data science forum. So you can leverage that also. And everybody either, and not only inside Altair, but our customers also publish different case studies, different success stories or something. So which will be based on your interest. You can go through that to understand what is happening in the engineering data science stuff. With this, I will conclude.